Good morning. In today's lecture, we will see about the introduction to Canvas system. In this lecture, we will deal with the basic principle of Canvas system as well as its data transmission principle. Okay, so we will see one by one. I am Nilesh Chandgode, trainer, Autotronics course, Don Bosco ITI, Chinswad. So we will move to next slide. Introduction. What is a bus system for? The use of CAN bus system in a car makes it possible to network electronic modules such as various different control units or intelligent sensors such as wheel angle sensor, wheel speed sensor, engine speed sensor, like this. So basic use of this CAN bus, or why we use the CAN bus system, to connect different controllers inside the car so that they can communicate to each other, they can share the information, they can transmit their information and use it. Okay, basically to connect the different types of controller via a common wires. So that is the bus system for. The abbreviation CAN means controller area network. So CAN stands for controller area network. So all the controllers are connected to each other by two common wires, CAN high wire and CAN low wire. Now, principles of the CAN data bus. What is the principle? So you can see this image. In this image, there are three different junctions. So where are these? 1, 2 and 3. There are three different junctions. These are connected to a common highway. This is the highway, and on which bus is traveling. So this is the omnibus which is traveling on the highway, and that highway is connected to different junctions. So it means that from various junctions passenger can travel on the highway. So all the junctions are accessible to the passenger. Okay, so similarly CAN bus system is, you could think of a CAN data bus as an omnibus, like the omnibus that transports many passengers. The CAN data bus transports a lot of information. This is a similar concept to the omnibus, which is transporting many passengers from one junction to other. Okay. Now, what are the requirements? The requirements of driving safety, driving comfort, exhaust gas emission, and fuel consumption are increasing continuously. So, I have to increase my performance of my car vehicle. I have to increase my efficiency, driving comforts are there, safety parameters are there, which are increasing day by day. So, to meet that requirement, my data transmission within the vehicle must be very fast. To enable this, this CAN bus systems comes into action. To ensure that the share of electronics remains manageable in face of this and those does not take up too much space, a technically advantageous solution is required for the exchange of information. So I required a solution which does not require more space, which is a simple in construction, so easily understandable. So these things are there. To overcome these problems and to give a one solution, the CAN bus system comes into the action. So who firstly developed the CAN bus? The Bosch. Bosch is just a solution, CAN data bus from the Bosch. It was specially developed for use in the vehicle. Firstly, they uses this system in the vehicle. Further, in automobile sector, in military sector, in manufacturing sectors, in robotics sectors, CAN bus systems nowadays using. In computer network system, CAN bus is there. CAN stands for Controller Area Network and means that the control units are networked with each other and exchange data. The CAN stands for, as I earlier stated, the CAN stands for Controller Area Network and means that all the control units within the vehicle are connected to each other via a common wire so that they can exchange their valuable information. Now, what is the data transmission principle? So, as you see in the vehicle, there are three different controllers: 1, 2, and 3. So, these are the three different controllers which are connected to some component or local interconnect network via CAN wires or LAN wires. Okay. What acceptable methods of data transmission are currently available in the car? Now, what is the data transmission methods currently available in the car? So, first possibility, each piece of information is exchanged via its own line. Suppose I have to make headlight on, so I required one separate line, separate bulb assembly, halogen bulb assembly, and I required a separate controlling mechanism to make switch on and off. Instead of that, so it required extra wires, extra bulbs, extra switches. If I move further to CAN bus system, it requires only one control unit, and that electrical control unit within the vehicle will control all the electrical activity of the vehicle. So you can think of that, how many wires are saved in this case. Okay. For each piece of information, a separate line is required, as I stated earlier. Thus, as the amount of additional information increases, so 2 does number of lines are there, number of pins and control units will be required, so its number will be increased. Therefore, this type of data transmission is only feasible for a limited number of pieces of the vehicle. So it is not suitable for a whole vehicle, it is suitable for some limited functions of the vehicle. Now, what is the second possibility? All the information is exchanged or shared via a maximum of 2 lines, the CAN data bus, between the control units. So instead of using separate line for a separate function, I use 2 common wires to which all the controller are connected, and thus they can share their information to each other via these lines. So there is a less complexity. It saves my space, it also saves my cost. So this one is the, as you see in the earlier case, there is a complex network of wire, but in this case less complex network of wire. Okay. Now the principle of data transmission. What is the principle? Okay, so as you see, there is a wiring network communication is there. Suppose consider there is a teleconferencing is going on. So each subscriber in this case is connected via 2 yellow lines. You can see this yellow line. So each subscriber is connected to each other via these yellow lines, and one, in this case, one is the subscriber or a speaker and other are the listener. One speaks, and accordingly other learner or listener listens its instruction, and that instruction is received by each and every person. Okay. Data transmission with the CAN data bus work in a similar way to a telephonic conferences. Okay, so data transmission principle is similar in CAN system as in telephone conference. One subscriber, that is control unit, speaks its data into the line network. Its data get entered into the line network, while the other subscriber listen to this data, and some subscriber find this data interesting or useful, and then this that subscriber will use that data, and other subscriber will skip that data, okay, and the other don't, right? So like this, the data, someone find that data useful, someone does not find that data useful, so other will skip it, and the person who want that data or set of instruction, it will follow that instructions, okay. Now in this figure, this is the data bus networking of the whole vehicle. This is a Golf 5 VW model, uh, and in this there are different control units. So this one, this one, this one, this one, these are different control units, and these control units are connected to each other. So in this data bus networking, as I stated earlier, I have marked different controllers in this diagram, and these controllers are connected to each other. These yellow lines, you can see these yellow lines, to each other, so that they can share share their information, so that data transmission can takes place, and accordingly action of vehicle takes place. Thank you. In next slide, what are the advantages of CAN bus system? In this, the first advantage is data can be exchanged between different control units on a uniform platform. So there is a one single platform. There are no other platform to share their data. So complexity is less in that case. It is simple to understand, and we can connect different controllers to a single line. Okay. So second, system involves several control units. So several control unit can be involved, and they can implement their functions efficiently. They can perform their functions efficiently. Okay. So there are different control like ABS control unit, electrical control unit, engine control unit, other sensor control unit. So different control units are connected to each other via a single common platform. In this case, system expansions are easier to implement. Okay, so I can easily expand my system accordingly my need. Now fourth one, the CAN bus is an open system which permits adaptation to various transmission media such as copper or optical fiber cables. So if I have a single unit and single wire, so my use of wire is limited. In that case, I have to use a copper wire. But in CAN bus system, I can use either copper wire or optical fiber wire. Accordingly, the cost plays very vital role in this case. Now fifth one, the control units are diagnosed via the K wires. Inside the car, diagnostic already takes place via the CAN bus in some cases. So in our system, in CAN system, diagnostic is possible with the help of K wires. So in wiring diagram, you can find these wires, K wires. So basically these wires are used for a diagnostic purpose. But in some context, virtual in upcoming year, there may be no K wires for the diagnostic purpose. So there may be some advancement in this case. Now sixth one, a cross system diagnostic is possible across several control units. So instead of diagnosing at a single point, I can make a diagnostic of a car at a different multiple locations, and a cross diagnostic. It means that I can check if I connect my connector, if I adapter for diagnostic purpose at a rear end, so I can access, I can have also have a access of front controller. Okay, so you can get it what I am saying. So if I connect the controller adapter at rear controller, so I can check, even though I can check controller which is situated at the front of the car. So cross diagnosis is possible in this case. Thank you. I hope so you are getting whatever I have taught in this session. Thank you.